I'm pleased to be here, so thanks for coming. What my general research interest is in the gap between values and practices. What we think we should do, what we're trying to do, what we want to do, compared to what we actually do. The last few years, we've been thinking about this in a very practical sense, which is in terms of scientific values and scientific practices. How it is that we have very clear values for what science is and how it ought to operate, and we have practices that do some of that, but not all of that. And so what I'd like to talk about is sort of the accumulated effort, both on the conceptual issues, but then on practical ways to try to address this gap between scientific values on the one hand and what we do day to day in our research. And so I'll start with just some overview of what the core problem is, as in very brief summarized form, and then summarize through the Center for Open Science how it is we're trying to do things about this. And I'm happy to be interrupted with questions and discussion as we go. So in the last few years, there have been a number of articles with forbidding titles and discussion, such as this one that came out in Nature 2 years ago. Believe it or not, how much can we rely on published data on potential drug targets? And the team that is reporting in this article did an investigation of 50 or so high potential, high impact, groundbreaking research, mostly in oncology, but in a couple of other domains as well. And they were trying to replicate the original results in order to translate it into some clinical therapies of different kinds, new pharmaceuticals or whatever. And they had a very difficult time even reproducing the original results. So in one investigation, about 11% of the 50 or so studies that were able to reproduce the results as they had been originally reported. A related investigation was able to reproduce 25% of the results. These are published high-impact results. Now, a reproducibility rate of 11% or 25% is far lower than we would anticipate, given the system of publishing what we presume to be the likely false positive rate, or at least the reproducibility rate in science. So there have been a number of researchers in metascience trying to understand how it is we're getting to a literature that may be less ideal or less valid or less reproducible than what we expect it to be. Daniel Finelli has done a number of studies, and this is one of his figures from a recent paper where he just went through a number of different fields, sort of meta-analyzed how much of the results published across these fields are positive results, supporting the hypothesis proposed in the paper, rejecting p less than 0.05. And what he finds is, across disciplines, on the x-axis here is the proportion of papers that are supporting the original hypothesis. And from physics through psychology, 85% or more of the reported results supported, rejected p less than 0.05 and supported the original hypothesis. Now that's a great yield of positive results, but it is a really great yield of positive results, suggesting that we have lots of good ideas in advance that are almost always confirmed. Now, this is interesting to consider in comparison to a large body of research about the power of individual studies. This is one that we published last year, doing a meta-analysis of meta-analyses in neuroscience, examining the power of the investigations across these fields. And what we found in this particular investigation was that the average power, depending on the sub-area of neuroscience, the average power of a study was between 8 and 22%. Now, what that means is that if every investigation we're studying an effect that was true, we would expect the positive result rate, given the power, to be between 8 and 22%. But what I showed you back here is that if for, where is neuroscience? It's neuroscience and behavior. Positive rate is somewhere around 85%. So if the reported positive rate is 85%, and the power is 22% to detect positive results, something is not right. Right? There is something wrong, actively wrong, with the publishing and what we're getting out of the published literature that doesn't align with what ought to be happening. Right? And there's lots of ideas for why it is we're getting this misalignment. We'll summarize those very briefly. But one of those is the flexibility that we have in how it is we conduct our data collections, analyze our data, and report our results. If you haven't read this paper, it is very worth reading. It's only like 5 pages long, and it's a really nice read. But Simmons, Nelson, and Simonson demonstrated with a great rhetorical argument and an empirical argument how it is that very common things that we do in our everyday analysis and reporting can massively inflate the rate of false positives. So I can actually summarize it briefly. So for example, we can look at our data and then say, oh, we got P.07, I need to get it below 0.05, let's just add another 5 subjects. Let's add another 10 subjects and see if we can then reject the null and get it to that magic 0.5. Right? This, of course, making a decision about whether to continue or stop data collection based on the results as you have them is going to inflate the false positive. We can conduct multiple analyses or include multiple manipulations or include multiple outcome measures and then just report the subset that work, that look good. But of course, to the extent that we selectively report different types of data, different types of findings, different types of analyses we do, we're going to inflate false positive from the data that come out are going to look better than they actually look. And then finally, we have lots of incentives to try to present the stories that we construct from our analyses that are ones that are essentially post hoc, right? They're discoveries that we have. Present them as if we had anticipated them all along, right? The good story, the good paper presents it in the confirmatory format. But of course, confirmatory formats are very constrained, right? You have to have everything defined up front so that the p-values have meaning. You don't have flexibility in the design and reporting. You report exactly as it's designed. Whereas exploratory research is vitally important, but p-values no longer have meaning because you are adventuring in the data. You are no longer constrained through false positives rates. You can't calculate the false positive rate, so the discoveries are necessarily more tentative. So when they're mixed, it's very hard to know how confident we should be in any particular result. So all of these things are related to this idea that they are creating a more beautiful story than the data actually are providing evidence for, essentially giving us pretty pictures that aren't as pretty as they are. And so this kind of flexibility has led many to have very dispiriting conclusions. John Ioannidis, this is his most famous paper of 2005, that is, the forbidding title, why most published research findings are false. And he just basically reviews the analytic argument, given a lot of these assumptions and the things that we know about flexibility and analytic strategies and reporting, what proportion of the research literature ought to be true. And he finds that not much of it. That just based on these practices, we may actually be creating a literature that doesn't have a strong empirical foundation. So to summarize the general tenor of a lot of the discussions, especially in the last few years, there are concerns with power being too low in our research designs, that we have questionable research practices, that we have this flexibility, and we take advantage of it in ways that may be inflating false positive rates, that produces an overabundance of positive results. We're encouraged to ignore the null results because null results we have an intuition that they must be less interpretable, and they aren't desired. They don't get as reinforced in publication. Replication is not as part of the standard practice, even though it's a core ethic of what science is all about, because we're incentivized to just innovate and not verify once we have an initial. And null hypothesis significance testing has limits, and they're not properly followed. Now, these are all the points that are being made in many of these discussions of methodological issues over the last 3 years. But of course, if you read from 1959 to 1975, all of the exact same issues come up and are discussed ad infinitum. They're very well-known problems, and they have been challenges for a long time. And those same articles, and I'm just summarizing a selection of them, identify what the solutions are to address things. Right? So we need more transparency in the research process, availability of the data, availability of materials, so that you can see how it is that the researchers got to their inference or reproduce their results. Make it very clear which are actually strong confirmatory designs with lots of constraints on how the analysis and reporting is done versus results that are exploratory, necessarily more tentative, but lead to an inspiring research approach. improving the likelihood of actually doing replication and incorporating that and the cumulative evidence into results. And then aggregating evidence. This is the one where we've made the most progress as meta-analysis is emerged as a standard practice. And then narrowing the use of null hypothesis significance testing to actual hypothesis testing rather than as the catch-all that we use it for. Now, if we've known since the 1970s about the problems, and we've also identified many things that we think are solutions, why are we still talking about it 40 years later? And the primary challenges we see is that we have not yet identified good implementation strategies for how we incorporate these kinds of solutions into the daily workflow and address what we see as the central problem, which is that the incentives for my success as a researcher are focused on me getting it published, not on me getting it right. Right? My reward, my getting a job, keeping a job, getting accolades is based on where things get published, how prestigious they are, and how many of them get published. At least that's the common perception. And so if we don't have, but also we know that not everything gets published. Right? We're more likely to get published if it's a positive result, if it confirms our hypothesis, if it's novel, and if the story is clean. And to the extent that I have no results or ambiguous things or other things, then it's less likely to get published and less likely to get published well. So I have strong incentives to make my stories as beautiful as I can, as positive as I can, and ignore that other stuff, because it's not in my interest in order to get these things published. So this creates a conflict of interest for me. Right? It creates a conflict of interest in what's likely to be rewarded versus what we actually find. And my lab is probably very much like everybody else's research, which is we don't really know the answers of the stuff we're studying. That's why we're studying it. Right? We're at the boundaries of knowledge. We're fumbling around. A lot of stuff that comes out of it is messy. It is uncertain. And so the fact that we don't have a good handle on the phenomenon is part of the process. And so making it look more beautiful than it actually is may be interfering with our ability to get to more accurate science more quickly. But there are lots, we can understand those ideas in principle, but there are lots of challenges for how we actually implement those solutions and make progress on making our science more credible and reproducible. The first is that the perceived norms in the field. So there are many norms of what science is and how it's supposed to operate. And these were articulated by Merton many years ago and are understood as sort of common practice for what scientists do. So standard norms of science, communality, right? It's open for critique, provide the basis of evidence for any particular scientific claim. Universalism, you evaluate the research on its merit, not on the reputation of the researcher that says it. Disinterestedness, the scientist is motivated to try to understand, to produce knowledge, to discover things. Or the counter norm for that, self-interestedness. I just want to get ahead of Jamie and make sure that I publish before him. Just the happiness that he discovered that is not something I get to happen. So organized skepticism, right, that we consider all new evidence, that we're open to having our current beliefs challenged and updated, and our own theories, versus the counter norm of dogmatism. Right? My whole career is about defending that finding I had in grad school. And then pursuing quality rather than quantity of research outputs. So when you ask people, scientists in particular, what norms do you endorse? The answer is very clear. So this is a survey of something like 2,300 scientists, early career being postdocs, mid-career being people that have gotten their first R1. It's across a variety of disciplines. And what I'm showing here on the x-axis is the percent of people endorsing the norms over the counter norms in gray, and in black are people that endorse the counter norms over the norms on average. And so you get 90% or better of people at both career stages saying, yes, those norms are what I subscribe to. That's what I believe a good scientist is and does and should do. When you ask them, okay, don't tell me what you subscribe to, tell me what you do, it moves down some, right? They still are largely saying, I do follow those norms. The hatched bars are sort of even, right? Both of these things are influencing my behavior. And black is, again, saying that I'm doing the counter norms more than the other. When you say, okay, don't tell me about your behavior, tell me about other scientists' behavior. So the challenge here, of course, is that everyone says these are the right ways to do it. I'm mostly doing it myself, but all those other creeps, they're not doing it. Right? And so that puts us in a very difficult position, as we know from human behavior. If we think that everyone else is following different norms than we are, living up to these norms of science is very difficult to do, especially if the counter norms can have career advantage. Right? If it makes it more likely for me to get published, for me to advance in my career if I pursue the counter norms, given the incentive structure, then how am I going to stay on the norms that I would like to stay, those ideals? So that's one problem. The second challenge is that we are fantastic at reasoning our way into seeing the results that are best for us being the results that are the right results. Right? So I have multiple ways I can analyze this data. We look at it, we try this exclusion and that exclusion, we're exploring the data, and then suddenly a result pops out that looks wonderful. And then all of this cognitive architecture comes to bear to say, well, of course this is the way we should have analyzed it in the first place. I can't believe we did this other thing, and why would we have even concluded that condition, and blah, 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 blah. And then we get ourselves to reason our way through saying this is the right way to do it. But the only reason we're thinking that way is because it looks good for us and for our publication. And that's very hard to undo. It's hard to even see it happen. It just sort of happens. We know a lot about it. A third challenge is that you don't know what happens in my lab. You don't see it. All you see is the final report. And David Donahoe, a computational scientist at Stanford, likes to call the published report advertising for the science. Right? It isn't the science itself. All of that is the stuff that went in every day, the data, the materials, the process of doing the analysis, all of those other things are summarized in that report. They aren't contained in it. And so there is very little accountability for how it is we get to that point. There's no transparency of the process in the standard practice today. And then a final challenge is that I have a lot to do, and so do you. We are working very hard, we're doing lots of things, we have lots of demands on our time, and the ideals are hard work. Right? Doing things to follow those ideals requires us to do more in the present practice than we're already doing now. And so even if I have those ideals, even if I embrace those ideals, actually following through on them means that I'm going to go slower. And that's another career disadvantage for me, right? I'm not going to get as much done if I have to do all this extra work to follow these transparency of distinguishing incremental results and slowing down my publications. So these are big barriers, and they make it very challenging for us to think about how is it that we can shift this infrastructure of how science gets done. But those are exactly the things that we are trying to resolve with piece by piece through the Center for Open Science. So I just want to introduce it very briefly and then talk about some of the initiatives that we're developing to try to address those formidable barriers. So the Center was founded just this past January, where actually tomorrow is our 1-year milestone of initial funding. It is essentially a technology startup. It's a nonprofit. And it's mostly developers, and we're building free open source tools. So the center is not developing any intellectual property of its own, it's just building tools that are free for others to make use of to the extent that they want. The primary activity is infrastructure development, and then we also do community work trying to address the fact that how can we shift these incentives and standards by engaging researchers, societies, funders, all of the different stakeholders in the scientific process. And then also we conduct and support meta-science, so research about scientific practices and how can we try interventions for particular behavioral changes and see what we can, whether they are effective in shifting behavior. So, but the global mission is to improve openness, integrity, and reproducibility of scientific research. And that's not limited to the social, education, behavioral domains that we inhabit, but just scientific research in general, because these problems, as we described earlier, are pervasive. Scientists all have these incentive structures that advance their own careers. So the general strategy that we're pursuing has 4 components. The first is to build services that support the workflow as researchers do things right now. This is the essential goal because of the busyness challenge, right? Is you have a lot to do, and if we can't build services that integrate into how you do it now, you're unlikely to adopt them. And so if we can do things to meet people where they are, solve problems for what they have right now, then those services will provide value for researchers doing the research that they have. and then with those services enable practices to get closer to these ideals and values. So we don't require their use, we just try to make it so the tools that are providing value for everyday research make it easy to be transparent, make it easy to distinguish confirmatory versus exploratory designs. And then if we can have that system and have people using that system, then we can work on nudging the incentives to try to provide reasons that people would start to adopt the practices that actually are aligning their goals for surviving in the field, for thriving in the field, with their goals for getting it right, for trying to do why we got into doing this research in the first place. We didn't get into research to get rich, because we're not getting rich. We got into it because we're curious, we're trying to solve problems, we like the process of discovery, all these different motivations. How can we make sure those are at the fore for how it is we do our research getting right? And then finally, there are some ways I'll summarize very briefly at the end that we can do some of the work collectively for those parts of the process that aren't incentivized to do individually. Okay. So I'll go through each of these just to try to give you a sense of how it is we're trying to pursue it, and do feel free to interrupt if you would like to talk about it. So the services for supporting the existing workflow, I'll give sort of an amalgam example of something that happens in my lab all of the time, and I bet it happens to you as well. So Anoop, which is hard to see, but Anoop is a second-year grad student in the lab. We have a weekly meeting, we're talking about ideas, and then sort of halfway through the conversation, we're like, oh my gosh, this is just like this study we did a few years ago that line of research totally died out. So what you should do is get that data and materials and use that as a pilot to start, so you can get a real jump start on pursuing this research question. And Anoop says, great. And so I go to my laptop, and I can't find the files anywhere. I don't know where that stuff is. I said, well, Nicole was leading the project. She graduated 2 years ago. So I'll just email Nicole and find out where those materials and data are. And Nicole's now in industry, so 2 weeks later she writes back and says, what are you talking about? And so we have some back and forth over the next week, and then she says, oh yeah, I remember that study. So let me go look at my computer. She says, I can't really find it, but I'll get back to you when I can look, because I know I have some backup files somewhere for this, because I've been doing this for a few years. And so a few weeks go by, and eventually she comes back and she says, I found it. Well, I found something. So I found these 4 files. I don't remember which version of the materials we actually used in the study, because remember how we were thinking about some changes, but here are all of them. And here's the data, but I can't remember which data file is the one that is actually the final data file. So here's that too. And Anoop says, I'm going to work on a different problem. It is ridiculous that we can't keep track of our own research for our own use. This isn't talking about sharing it with other people. It's the lab ourselves for losing things. What a waste of resources that we have. And this isn't like this happens all the time. It's happened twice this week for old research. I'm not joking. Twice this week, old research, we say, I don't know what the materials were. We just don't have, and I'm an organized person. Our lab is pretty organized. But we're working on a lot of stuff. We're working fast. There's a lot of different people involved. And so keeping track of that effectively is very difficult. And we assume, right now I understand what VAR 0001 means. Of course I'll remember that. Right? And then 6 months from now we'll go back to the file. What are these variables? I have no idea what this is. Right? So we're just not documenting and tracking and archiving our research as effectively. And so that's the problem that we started with. Can we help people, and ourselves in particular, keep track of their own work for their own use? And so Jeff Speeds tackled this as his dissertation here at UVA. He finished in May of 2013 by building infrastructure. So you can actually use the infrastructure, OSF.io. So the Open Science Framework is a tool that we've been working on, and now the center is supporting. Most of the staff at the center are building this tool to help with archiving, documenting, and maintaining the research workflow. As people do their work, making sure that there is a place that will help organize and maintain that so they don't lose them. So I'll give you sort of a very simple tour of it, but then encourage you to go try it out. There's little videos at the website to give a more specific tour. You can just register an account, which takes 30 seconds, and start using it to try it out. We have staff that are willing to come over and do actual trainings, or can do it as a virtual hangout, or you can come visit us. We're actually in the London downtown. So there's lots of places if this looks interesting. So the idea is to support the entire workflow. The way that people are working day to day and doing their research is having a home base, essentially, that connects the different things that they are working on and provides some way to maintain, especially among collaborative groups, the materials and data that they're working on. So you go to the website, you sign in to your account, and then you have a dashboard of projects. So all projects, it's organized by projects, collaborators, and then components within those projects. So I want to create a new project, so I click the new project button. I give it a name, I have a very brief description, and then I say create a new project. What is created is a workspace that has lots of familiar Web 2.0 features. Right? There's a general dashboard, there's a wiki for maintaining notes, and it has version control history of what's changed there. You can upload files just by dragging and dropping them from the desktop to maintain those files, the materials, the IRB, the data, etc. And there's some other features. I'll mention some of them. But Johanna, this is Johanna's project. So she's created this project, and now she wants to add some components. Components are discrete entities of the project. Right? So you might have the materials as one, you might have the data as another, you might have the analyses as another component. Particularly if you want to segment how it is you maintain those files. Right? There are different contributors at different stages of the research process, or you want more control over which things are maybe more accessible to others or not. So you create components, and then she has collaborators, and she wants other people to be able to have access to it. So you go and you click add, and then she finds her collaborators in the system. She submits, and now they have access to that workspace as well. So it's a private workspace. It's just for the collaborators, and they all have a shared environment that's web-based for posting their materials, their files, their data, etc. So what should have happened when Anoop came to my office is once we figured out what the study was, I should have just been able to go to my dashboard, find the right study, and then add him as a contributor. And if we had been using the system as we were developing the study materials, as we were conducting the research, all of it would have just been here. And so he would have been able to trace the entire history. The website is version control by Git, a system, GitHub, if you've heard of it, uses Git as a version control system. So every time you post a new version of the file, it's automatically versioned, and you can access all of the prior versions of the file and see the change sets between what changes from one file to another. You do this informally now with your papers, right? You get a paper from a colleague, you add your initials at the end, you send it back, they add your initials at the end, you have the date at the end, and you make a big change, and then you have this sort of file tree in your file system of these version controls. But of course, you have multiple collaborators, and they edit different versions of it, and then you have to do all of the merging of all of those, and it becomes a huge pain in the neck. This manages all of that for you automatically. You just post in the version of the file, the next person pulls it out, pushes it back in, get versions into the next system. So that would have been the ideal. And this is just illustrating how you either click and say upload this file, or you just drag it from your desktop right onto the window. Please.
Is there a size limitation, or do the files that you upload live in Open Science, or do they live like on UVA and just link to them through Open Science? Because I feel like it can get really big really fast.
Yeah, that's a very good question. And so the next thing I show you is going to address exactly that. So thank you for anticipating. So I'll get right to this issue. So this is trying to help support the workflow as people do it. Right, you're developing an idea, you write materials together, you post it. You get the materials back, and then you get into actual experimental design. You get the data collected, you have the data there, store it, whatever. So what the OSF really aims to do is connect services together that support these various functions. It has a core set of functions that it helps to maintain, but there are a lot of services out in the world that do these things, and you use a variety of them, right? You might use Google Docs for some authoring. You might use different places to store data. We'll get to that in a second. You have different analysis tools you use, SPSS or R or SAS or whatever. You have different tools you use for visualization or writing. You have to interact with different services, such as the IRB system at UVA, which is just a form and you fill it out and you email it. But that's still a workflow that is distinct from the workflow that you use to apply for grants when you apply or whatever for that grant system. What we aim to do is connect those services together through the modern web technology called APIs, Application Programming Interfaces. Essentially what that is you allow services to develop separately, be completely independent, but you teach them how to talk to each other. And so the OSF is essentially an API hub. It's connecting these different services together so that it can simplify the transition costs for you, moving from IRB to grant submission, to data collection, to data visualization. If we can connect these together, then the different tools you use can talk to each other. And it's much easier to keep track of what happens, but then it also makes you much more efficient. So let me give an example with the storing data, right? There's lots of data, especially if you do fMRI research, if you have huge data collections with many sites and tons of data coming in. We have our own data repository that you can store it in, but there are lots of occasions where you need other kinds of data repositories, either for very big data or that have particular structured formats. So what the OSF will do in this connecting services is provide API links to a variety of different data repositories. Now, these may not be familiar names to you, but there are many, many repositories that provide services for researchers or whomever that want to store large data. And so we have launched the Amazon S3 integration already. Figshare should be launched tonight, if all goes well. And we're working with the Dataverse group at Harvard to integrate with them. And we have planned ones for Data One and Dryad. But there are many others. There's hundreds of repositories, right? UVA has its own repository for data and papers. And we would love to have API connections at the institutional level as well. So what you would do when you log into the OSF and you're ready to post some data is you would start a data component and then a menu would come up. Which repository would you like to use? Just the OSF native system or one of these other systems? And there might even be a wizard that guides you. What kind of data is it? How large is it? What needs do you have for security? And our HIPAA standards, right? Some of these are HIPAA compliant, some of them are not. If you have location constraints, right? Some European data must stay in Europe. And so you have that. So if you can go through a wizard and say, here are the available repositories, this is how it fits my need, then it would suggest, here are the three that would fit. And so you create a data component like that, and then it integrates with your other work. So this is just to illustrate the Amazon Simple Storage System service, right? Amazon S3 it's called. You probably have never used this because it's a little bit out of the sort of standard workflow for researchers, but it's a very useful service for storing large data. So we integrate with it so that you can add an Amazon S3 account. Then you just select one of the buckets. This is how data is stored in Amazon S3 buckets. They're not real buckets. But then that Amazon S3 data and files are just integrated with the file system as it appears on the OSF. So it's as if you have a single file system, but the actual storage can be in many different places. And it just looks like what your desktop will look like. We're hoping within 3 weeks, we'll see, that we'll have integration with Dropbox and Box.com, which would mean that you can set folders on your desktop, integrate this with this OSF project, and then those files, as you update them on your desktop, which is how you do your daily workflow, they're automatically getting updated to the system. And so then all of your other researchers can be confident that the files that they can access here are the files that are the most current versions of it.
I have a quick question about that.
Yes, please.
So just to clarify, especially using Dropbox as an example. So this is sort of like almost having sort of a permanent link. So when you're using Dropbox, you can request a link that you can give to other people and they can download stuff from that website. So this is almost like you're kind of setting up a permanent link that other people can access that's sitting on the OSF. The files themselves do not get copied into OSF. So is that correct, or that?
That's correct.
So the files will only, so it's not like you're making it available to anyone at COS or anything like that. So you're just providing links that other people can see to access and download the files.
That's right. We just manage the interaction with those files. We don't have the files themselves. Right? So they sit on Amazon S3 or wherever else. We just provide a directory structure and navigation to help with making it smooth to move it around.
Now, are there any plans to have files that are natively on OSF have something like a Dropbox type interface where you could have a folder that you identify as this is my OSF folder, and anytime I make changes to this, I want them automatically updated and put on the...
So we'll do that through Dropbox.
But you're not planning on doing that independently?
Well, we are going to do it independently, but I think because there's already so much use of Dropbox and Box.com is becoming more popular, that our first goal is just to integrate with those since people already use them, and then we can do the other one later, right? So it's a matter of resource time investment. Okay, we can solve 80% of the problem by integrating with those services, and then once we integrate with, have this available as just an OSF general or OSF native function, then people could not even have Dropbox accounts but still get this in the value.
Okay.
So we'll do what you do if you have a Dropbox account. We'll do what you want if you have a Dropbox account, and then you'll eventually have it adjustments. Mm-hmm. Yeah.
So just to follow up on Jamie's question, so I'm concerned about security issues, right? Because the granting agency gives the contract to University of Virginia, and ultimately the data are the university's data, right? So, or actually the IES's data are whatever. But so I'm worried about the security of data and files. So the security would still be with. Can you talk about that?
Yeah, so what we maintain, so we don't have the data when you use one of these repository files. There are some where we would provide the service for backing up those data if that were of value, but you would have some warnings of what it is that you're sharing and not sharing. So different repositories have different security standards, and so that'll be an important consideration for anywhere you store your data, right? So if it has to be local, then you have to keep it local. If it has to meet certain standards, where is it that you would put it? What's stored on the system from our side are hashes of the data. So it doesn't have any meaning itself. It's just a way to sort of have a key for, is that the data that you're looking for? And so that hash is what gets recorded over time, which is a 16 or a 30-digit string that is essentially a summarization of what the data are. And that's how we do version control on our side. So we maintain those hash histories so we know, did you change the data, but we don't know what the data are.
I'm not sure everyone knows what a hash is, because I only have a vague idea what a hash is. Could you?
It's a code. So, you see hashes for things on the web. They're just appear to be random letter strings, right? So you have some code when you have open a Gmail address and it has XV472872, right? That's an ID identifier. A hash is one of those things that's created by analyzing the data, and analyzing the data not in the way that we analyze it, but rather, how do we summarize this data? You run an algorithm on the data, and it creates a hash, and that's going to be unique. Any change to that data file will change the hash, the output ID. And so it's a way to link, without knowing anything about what's actually in the data, a way to create a code that lets you know, has anything in that data changed? Help you. Does that help?
So you want a persistent URL, or it gets you a unique number. Here's
right.
This version of a book, here's that version.
That's right. Yeah. And we have all persistent IDs. So every page, every component, every project has a persistent ID, like DOIs. But now they're general identifiers and they're open identifiers. So all of that is maintained. Yeah?
You mentioned Box.com, including UVA's Box?
So we'll integrate with Box.com services. We don't yet know what the constraints and limits will be, but that will be explored as soon as we get the beta version done. But I'm hoping so. Yeah, it would be great to be able to integrate with those enterprise services because that's what people are using. And then also institutional requirements sometimes have. So you need to use these services, or these are the ones that are appropriate for these kinds of uses. So if we can't provide that service, then we're not meeting the mission of what this is supposed to be.
Okay, so just so I'm clear, if you're working on a current grant right now, there are repositories that you can put that I'm working on. You're not archiving it because you're finished with it, but working.
Yeah.
So you put it up in Dataverse or wherever. So that's going to be very secure, and then you have all these tools to help you. And access to that data, a dataverse, you're running it and setting the limits as to what, who can get in and who cannot. So absolutely foolproof.
Absolutely.
Right.
With no possibility for
Right.
I mean, it's not any less secure than if we have a server somewhere that we're putting it on your local place.
That's correct. And in fact, when you can link to enterprise services that are very mature, you can be more confident in the security of those services. Right? Amazon has a lot of experience with doing these sorts of things, and so you know what their security standards are or not. And so the maturation of those, and Amazon is just one example. There are places that have different skill sets that are going to be better and more skills. Yeah.
So my question, I guess, is more selfish. So I hope to leave UVA one day, but still, and then be postdoc somewhere else. Hopefully using Open Science Framework. Will my personal login kind of organize my UVA project? So is that now?
So your login is yours. So it is an identifier just like your Gmail account. So it will follow you wherever you go. And it's only if your collaborators remove you from the project that you would no longer have access to it.
So that's awesome. That's it.
Right. And so that's really the goal, right? Because people are leaving my lab all the time. I hope because they're graduating. But I can't lose those data. But we lose an incredible amount of intellectual ability and knowledge when people leave, because they're the ones that know that stuff best. And so this is our main way now, as we've adopted this as sort of standard practice for our lab, to keep track of this stuff. Okay. So that we've talked about this in general. So I'm happy to say more because there's lots of other things that are in development for that. So if there are questions about can it do this, will it do this, that kind of stuff, we're working on all of it. So someone mentioned private links. So that should be launched tonight as well, if all goes well. Where you can send a link if you haven't added the person as a contributor, but you want to give them access to the materials, then you can give them a link that will last for 24 hours without adding them as a contributor, so that they can access and download those files and materials. Okay, so what I've described with the OSF so far is entirely for private use, right? Among your collaborators, how do you manage and maintain files and systems and data and everything else? The goal is to integrate those private workflows with the possibility of a public workflow. Right now, if you want to go into a public workflow, right, make your data available for others to use, you have to do a whole extra step, right? You go over to Dataverse, you build in that system, you create that data file, you document everything else. So it's all of this extra work. Often it's extra work after the publication, which is the point in time where most people say, I am done with this project. Why would I add more work in it? And so it's not likely to happen, right? Again, confronting the busyness challenge. So we're trying to integrate this private workflow with making it very simple to make things work. So on the OSF, there's a little button up at the top that sits there, make public, right? And all you have to do now, if you want to make something public, is click the button. And then there's another button that says, are you really sure? but it's there, and it takes 2 clicks. So it is very easy to move things into the public. The other thing that it does is if you use components, then you have lots of access control of exactly what you want to make public. Right? So we have some of these very big data sets that take a long time to collect, and the researcher leading that part of the project has 3 or 4 papers that they're planning. And so they're not quite ready right away to make all of it public. They want a little bit more time to get a couple of things done. But we might be perfectly happy to make the codebook public. And so if those 2 things are separate components, then we just make the codebook public. And then other researchers that discover that might say, oh my gosh, I have this great idea for a research project or a collaboration. And then we can consider those on a case-by-case basis of, oh, we're not going to do that kind of research, here's the data. Or, wow, that's a great area for collaboration. I don't want to work together over the price. And so that kind of control gives flexibility for encouraging some opportunity for openness, but not requiring. Another option that the system supports is registration. So this is this is one of the burgeoning debates, is how much should we incorporate pre-registration of research designs and analysis plans and hypotheses into the daily workflow of scientists. Right now, in clinical trials, it is the standard. In fact, it's by law that clinical trials have to have been registered in advance. That emerged because of the very clear conflict of interest that pharmaceutical companies and others have for obtaining positive results for the effectiveness of particular drugs and suppressing negative results for their ineffectiveness because there's a lot of money at stake. But the same kinds of incentives at a lower scale are present for us in how it is we do our research. And so this makes it very easy to register the project at particular points in time. And what registration is essentially creating a frozen version of the project. So you do your work as you're doing your work, and a useful time for registration for us is at the onset of data collection. So we click the registration button, and then we fill out a registration form. And it can be a very simple one. The simplest one is just an open-ended text box. Just explain why you're registering what the project is. So we put a few sentences and say, we're just about to start data collection, and so that's why we're creating this registration. We click register, and then a new version of the project with a unique URL is created that is a frozen, read-only version of that project. It cannot be deleted. It will never change. And it's always linked to the original project. So you click this project, you go to the active project, which can continue to change and evolve over time. But this registration is always there for how the project existed at that particularly important moment in time. And then we might register it again upon submission of the report for publication so that we can go back to it when we get reviews back and know what analysis scripts were like then, because we might continue analyzing the data as we go. And these registrations provide some confidence for us for how the project existed at particular points in time. And also makes it easy to do this pre-registration of a confirmatory design. Right? If we have a very strong hypothesis or we have a very clear analysis plan and we want to have those constraints so we can say, look, we hypothesize this advanced human tested exactly that, and there's the outcome. Then pre-registration provides an opportunity to demonstrate that. Right, here is a certified, date-stamped, what the project was, and I say explicitly that I am not committing. I could lie, but then I'm committing fraud. This is, right now, when we do it, I'm not committing fraud, I'm just forgetting that I didn't have this hypothesis in advance. But this changes that equation to have it be an active step. Okay, so questions or comments on that?
Is that registration still private? Like
so you can have it be private. Right, so you have complete access to
accountability for yourself and for others in your lab.
Yeah, so the idea would be that if you're concerned about getting scooped, for example, you don't want to make it public and have people know about that registration. You can have it just be public, but it gives you the flexibility to have a private registration that then you could choose to make public at a later date. Right? So we've now completed the study. Here's the registration we have in advance. There's no threat of people running in and getting your stuff on before we do. And this is what we have. Or you could leave it private forever if it's just for self-accountability. Other questions or comments? Okay, so let me give a little bit on how we're thinking. This is now we're going to go a little bit broader on how it is that people might start adopting these things. We have, for example, and we're hoping that people just find value in the system itself for its own use. But there can be incentives that are more connected to the kinds of things that we are aiming to do in the current incentive structure. Like get things published, have a work, get out there, have a work, have impact. There are some obvious things like alt metrics. So anytime you make any part of your OSF project public, it starts to count. How many people come visit your page? How many people download your stuff? How many people use your things? There's even a concept called forking, which is people can copy your project into their own workspace. If, for example, you created a measure that's really useful and other people want to use it, they fork that measure into their workspace, incorporate it into their project, and then it always maintains a link back to the original project. So that it's a functional link, but I'm actually using some of the research that you did. And that is much more information value, we think, form of citation than the standard citation of just how I was inspired by this in some way. and that entire forking history, right? So if someone else adapts your measure a little bit, and then someone else says, oh, I like theirs, and then uses that, and it changes over time, and continues to improve, or an analysis script that's particularly good, then the entire link history of how that's changed over time can trace back to you as the originator of that.
So you're able to set the fork yourself as a researcher, to open or not?
So if you make your stuff public, then others can fork it into their workflows.
And then do you also offer a citation for that? Is that
yeah, everything that has a citation associated, there's an automatic tool. If you go on the OSF, there's citations for everything. And then the forks are counted. So you see on your page how many people have forked this into their workflow. You click, and you get links to all of the fork projects. They might have them private, so you wouldn't be able to see them, but you would have an account. You would have a count of how many.
Do you see who takes them?
If they make their project public.
If they make it.
Right. So we will have a more nuanced permissions set soon. Right now, it's just public or private. What we'll add are sort of in-between kinds of permissions, which are, I'm willing to share this, but I want to know who is accessing it. Right? Because some people want to have some. Yeah, it's sort of flexible on that kind of standard. Is can we support the different kinds of licensing standards that happen in the daily workflow?
Very valuable.
Yeah.
Because you would know who's using your tool and you could collaborate.
Right. Right, and so that's the whole goal, is to make it so that it's easy to find stuff, easy to pull it into your system, and then hopefully that would actually encourage communication. All right, so there are things like that. Badges, we can have journals provide a badge on the article if you have open data, if it is available in a public repository, or if you pre-registered in advance. We have 8 journals that are piloting that. Psych Science is the most well known of those disclosure standards, what people are supposed to report. But I want to spend the most time or all the time for this one, on registered reports as something that we've been doing lately that I think is particularly interesting in a way to shift some of the incentives for how it is we pursue our research. So our standard approach in research is, the caricature form, is we design a study, we collect and analyze the data, we write a report, and we publish it. But of course, there is a big barrier, right? The gatekeeper is peer review after you've drafted that report before getting published. Registered reports shifts that. So instead of the peer review occurring after you've done the research and reported it, the peer review happens after design. So you design the study, you create your analysis plan, you show how it is you're going to do the research, you argue why it's important, and that's what you submit to the journal for review. The journal reviews it, the peer reviewers say, is this important enough that we need to know the answer no matter what the outcome? Is it important to the research? Is it designed well enough that we are convinced that this is good research based on what we know now? And then the action letter comes back and saying, if you follow, and if it's successful, if you follow your analysis plan and design as you propose it here or with these revisions, then we will publish it regardless of outcome. So then you collect and analyze your data, you write a report, and it's published, assuming you follow. So we have done this and with a special issue of the journal Social Psychology. Last year we put out a call for replications of important results in social psychology. And next month, all of the 15 registered reports should be released. We've finished all of them, and now they're going through the proofing stages for the publisher. We did exactly this. People proposed to do a replication of some important result. They say why the result is important, why a replication is needed, and how it was that they were going to do the replication. And then we took those proposals, we sent them to peer reviewers, almost always included one of the original authors, especially if they were alive, and then additional reviewers to say whether this is worth doing and whether their design was strong enough. Right? When you do it this way, getting a high-powered design becomes really important. Right? If you say I'm going to run 30 participants, you say, well, yeah, that's crazy. Like, you can't learn anything from 30 participants. If you get a no result, you won't know if it's a no or if it's because you were so underpowered. So all of the designs are very high-powered designs, and they have a lot of feedback up front about the quality of the design. rather than after all the work was done, then the reviewer is saying, you totally messed up the paradigm. Like, this is useless. You can't infer anything because you may have left out this critical thing. Instead, they get that feedback at the beginning before they even do the study. So the way this shifts in some important incentives are that it lowers the barrier to conducting replication. Right? We do a lot of replications in our lab, and it's primarily motivated for moving into a new area of research. Someone gets a phenomenon we think is really interesting. Our first step is often, well, let's see if we can get it ourselves, and then, so that we can extend it and do some new things with it. But it's often the case that we think, well, we're just doing the replications for ourselves. It's not something that's valued in the community. Innovation is the singular type of thing that's rewarded. So conducting a replication has high risk if the idea is to get it published, because there's a whole lot of work up front. And then you send it out to be reviewed, and then the reviewers say, oh, this is just a replication. Why bother? Or if it fails, well, you must have done it wrong, so why bother? So this lowers the bar because all you can do is write up the proposal. You don't actually have to do the data collection. And so you can get rejection with low effort, or you can get acceptance and be confident that regardless of outcome, even if it's a no result, that it will be published. That the reviewers said in advance that this is a strong design. And so disconfirmation of that is an opportunity to learn something, even as a no, right? Because the a priori perception of the project was that it was an effective test. It also addresses this challenge of when we're actually writing up our reports, trying to make it look beautiful versus trying to just tell accurately what we found. Right? We've pre-registered our proposal, we've pre-registered our design and our analysis plan, and we also have publication already, essentially. And so all we need to do is report what we found. We don't need to try to dress it up and make it look nicer in order for it to be publishable, because it's already publishable. That part happened before. And a fourth thing that we found, and we experienced firsthand with these 15 registered replication projects, was that peer reviewers are in a very different position when they're reviewing stuff before the research has been done versus after, particularly when they have skin in the game. Right? So what happens often, if you're in an area of some controversy, is that the people on one side will find lots of things wrong with your research, no matter how good it is. And people on the other side will find it to be the best research ever done, no matter how good it is. Because there's motivations, right? I have a stake in this particular theoretical position, and so this seems to challenge it, and so I'm going to find all of the problems that I can with it. When you don't know the results in advance, the mindset for the peer reviewer is entirely different, which is it has to entirely focus on the methodology. Is this an effective design? Will it effectively test the question or the idea that we have? And I don't get to know the result. So it prevents critiquing after the results are known in order to invent problems with research designs that if we had just looked at them beforehand, we might have actually agreed, oh yeah, this is a good design. So motivated reasoning works both on the original researchers and the reviewers of researchers. And we had some very interesting experiences with this in doing this special issue, because there was a number of reviewers in advance who would say, yeah, this is great, I'll do these changes, and then this will be a good design. And then the results came out, and then they wrote back saying, wait a second, no, there's all sorts of problems here. Right, just sort of illustrating this motivated reasoning, because they didn't like the result once it came out. So it's not likely that they would have recommended acceptance had they known what the result would be. So this is, I think, a very interesting approach to trying to shift some of these incentives as a complement to our publishing process as we did. Any questions on that?
So this makes perfect sense in lots of ways, and I'm just wondering, you've thought about this a lot more than I have just sitting here, but I'm wondering, you can imagine as the way you've described that there's lots of unintended consequences with the current system that we have, and it leads to all the things you described. My guess is there's also unintended consequences of this system that sort of play out. My job is done once I get the referee reports that my design was good. And so I'm wondering how you anticipate what those unintended consequences of actually doing the analysis and the lack of incentives that exist at that point in time.
Yeah, it's a very good question. Is maybe it will encourage sloppiness
Yeah, exactly.
Execution.
Or lack of curiosity, because I just published this, no result. We haven't dealt with the larger problem that is, I need 15 referee publications in these journals in order to get tenure, for example.
Yeah, that's a whole extra layer of challenge that this doesn't address directly, which is how is it that we as institutions evaluate and what role is that sort of feeding into this whole craze for getting multiple publications. So this doesn't solve that at all. The ideal of this for addressing the first problem, sloppiness problem, is that there is already transparency and commitment. Right? I already essentially have a publication, which is I'm doing this project. People are motivated and interested to see what the outcome is. And so the skin that I have in it is the only thing that I can do is show that we did it really well in order to bolster my reputation. Yeah, we have a good design, but the follow-through is going to be important, as important for my reputation, or more important perhaps than the actual outcome. Right? Because I can't control the outcome. That's all pre-registered events, but I can control technology. I don't know how it's going to happen. This is a test case, so we'll see if this actually falls through or if we end up confronting some of those issues. I think that it actually encourages more carefulness because it's public and transparent than our current system is, which is I can be as sloppy as I want. All I have to do is produce a result. If I analyze it badly and it's still less than 0.05, oh well, no one else is going to do it. Right? I'm not thinking that way, but with it being closed, it's easy for it to operate. Yeah.
Similarly, I think about some of the projects, for example, if you went through this process, some of the projects that you have to apply for the fund, how would this integrate with the funding you're needing to apply for to do the study you're proposing, and then the years it takes to... So in your view, would the acceptance from whichever editor was the editor of that journal that year, 5 years later when you're ready to publish the study, would that acceptance still stand? And did you review, in your process, did you review, was there another review of how they wrote up the study?
So just the editor handled it at the latter stage. Okay. So either Daniel or I was the action editor. And so we did a final review, checking against their original proposal. And we sent some back that they had to do more, right? There was a couple of them, for example, that didn't get to the sample size that they said they were going to. One of them only got half as many. And they said, well, it was a lot of work. Well, yeah. But you got to do it. That's the whole point. Is that it has to be a high-powered design. And so they did. They ran they doubled their sample size to what the plan was.
I can imagine that just even in the way someone writes things up, and the interpretations they take, and the lack of connection to the broader literature that they make would still require some sort of examination.
That's right. So yeah, it has to be. And there could be another full round of review. We didn't feel like it was needed in this case because we had a good handle on what the projects were. If there were statistical issues that we were capable of resolving, we might have needed to get some additional support, things like that. But we didn't, at least neither of us experienced that particular scenario in these cases. But I agree that there's lots of room potentially for that. On the bigger issue of over time, the idea would be that the acceptance is in a sense published when it's accepted, right? So the proposal becomes part of the journal, right? If only at the website, to say these are the registered reports that will appear in this journal someday, assuming that they actually are able to finish the data collection, right? They may not be able to get through. Whenever that occurs, right? 5 years from now. 5 years from now, there won't be any paper journals, so we're not going to be worried about space and all those things. We're just going to there may still be some. We're trying to solve that too. That's another thing.
I just wanted to follow up on Sonia's point. It just occurred to me that one way that this could work is in a grant-funded literature, because a lot of what you're doing is in social psychology, which is not usually experimental with undergrad subjects and stuff like that. But I can see you writing a proposal, getting it accepted as a journal before writing a grant. And then as part of the grant proposal, you could say, I already have a promise from Nature that if I conduct this study, it will get published. So you could actually get it accepted since you're not committed to actually conducting it. And then you can say, or this journal, or this set of journals, depending on once it's once we're in an electronic age, you have maybe published in multiple places. You can actually have a commitment to the field saying that they're interested in this research question, and they include that as part of the grant proposal. And maybe grant proposal will get to the point where they require that you have a journal sponsor already before you even get the money to conduct the.
And so the peer review process essentially takes the place of the grant review process. Right? To some degree. Right. The grant reviews now really this has already been evaluated, and we just have to decide whether it's worth our dollars. We actually have grants for these projects. The center gave grants for those accepted proposals, so they included a grant proposal for actually doing the work. They're small grants. Yeah.
So I totally get and appreciate how this works with sort of experimental design, where you're going to go out and say we're going to get 300 subjects and randomly assign. But how does this work, say, for quasi-experimental work, where perhaps much of being able to convince a referee is the sense of, is this a good instrument? So either you have to get much further into actually doing the analysis to be able to convince them that this is a good proposal, or the referees are taking on faith that you're going to be able to find, say, a good instrument to get some exogeneity, or this RD is, a good RD. So I'm wondering how applicable this is across a variety of methodologies.
Yeah, it's a very good point, and I think there are a lot of occasions where it wouldn't be the appropriate stance to do for this, right? So, in addition to what you said, which is like the psychometric development of a scale or instrument, registering in advance, like we'll publish this in our, maybe there'll be circumstances for that, but more likely it's going to be no, get your validation stuff done, and then when you apply that measure for your confirmatory test or your particular theoretical research.
So again, I get how that works with measurement, because you could publish an article saying we developed a good measure.
Right.
At least in the literature that I'm familiar with, public policy economics, you don't publish an article saying I found a good instrument for this. Right. That is part of the study, and so it's again, I think you could probably figure out ways to make this work. It's just not nearly as clean as it is in this experimental literature.
So we've been talking to some folks in economics and political science about this, and in addition to sort of broadening what you're saying is projects that aren't a very focused experimental design, but rather a very large data collection.
Okay.
Many measures, many years. Saying this is the proposal and this is the study doesn't make a lot of sense, right? So in those cases, it's more likely that you would have some standards for the review before observation of the outcomes. So the data may already exist, but if you haven't analyzed it yet, you can say this is the portion that we're analyzing, this is the part we're doing, or we're going to do this stage first and show you that we have the psychometrics for the particular measures. What we haven't done at all yet is actually do any of the hypothesis testing. And that's what gets reviewed. So you do sort of multi-stage process where you do some of it up front in order to provide the justification, but then hold on the key tests. That's going to be more complicated, obviously, to manage, but it's conceivable at least. What time are we at? 12:14. Does that mean we stop?
I don't know.
Not too many people taking questions as you've been going. I would say we could go for like another 10 minutes and just leave about 5 minutes at the end.
Okay, so I'll just do a short mention of the crowdsourcing stuff, and then we'll stop. So this is a section intended to illustrate that we can think differently about how it is we do our research for a lot of those questions that would be really worth doing but aren't possible to do, either because of their resource challenges or because they're not rewarded the same way, like replication. And so this is just to describe the contrasting models, right? So the standard model for how it is we do our research is vertically integrated, right? My lab has to do everything. The idea, the design, the data analysis, the data collection, the reporting, right? The individual researcher is supposed to be skilled at all the different parts that always maintain in a particular group, right? It tends to be resource intensive, right? We have lots of things that we have to do in order to pull that out. It's also exclusive as a model, right? Those that can actually follow through on doing an entire research process, research program, from ideas through follow-through, are R1 universities. They put a lot of resources to supporting laboratories, supporting graduate students, supporting all the infrastructure in order to get the research done. But we have lots and lots and lots of people that have tons of training that are at places that aren't resourced in the same way, right? That have lots of skills that can contribute to the scientific process. But the idea of teaching a 4-4 load and conducting a laboratory that's doing innovative research from ideas through follow-through with no graduate students is just not, it's not possible. So we're not using the resources that are available, right? Something like 88% of students in college are at not research-run universities, are not at research-run, or other places. And so faculty are also at those places, right? So a huge portion of the available talent is outside of the traditional system that gets research done. And so it's no surprise that the top 50, top 100 universities produce almost all of college research. But even so, it produces a lot of small science because my lab operates as my lab. It's not taking advantage of the fact that there's lots of available expertise. The complementary model to consider in a crowdsourcing manner is a horizontal distribution rather than a vertical integration. So my lab doesn't need to have, or I don't need to have all of those skill sets, or all of the access to data, or all of the analytic tools. Rather, there are many people that have different parts of those tools, many people that have access to data. And so if we take advantage of the fact that there are many people that can contribute in different ways, perhaps in just very specific ways, to a project, we can leverage the distributed expertise. Such a model is often resource light. If you do it modularly, where you're doing this piece, I'm doing this piece, they're doing that piece, then each person contributes in a small way to what ultimately accumulates into a large project. It's also a very inclusive model in that people can contribute just what they have available. Their available time, their available resources, their available expertise. So it's possible, for example, we have a number of projects with citizen scientists involved. Right? They're very interested in science, they don't have access, they're not in an institutional setting, but they want to contribute. And so they help with a literature review. They help with checking materials. They help with different parts of the process because they can access it based on what they have available. And if we do this well, especially if it's done modularly, you can enable big science projects. You can actually do more by distributing the load across many people, even though all of them individually are contributing less. So I have a few just examples just to illustrate this idea of crowdsourcing. One is a project led by Calvin, as a graduate student in the lab. That is a project in our main substance area, looking at how it is at implicit social cognition, particularly implicit race bias. And there's lots of research looking at how do you change implicit race bias. And so what we did was we organized a contest. We invited a number of different people from different labs to design a 5-minute intervention, any intervention they wanted, to try to reduce implicit race bias. And so we had a single design. We said, this is the dependent variable, this is how it structures, this is where your 5-minute intervention will get dropped in. Everybody got to design whatever they wanted for that 5-minute intervention. And then we did a very large-scale data collection to do a comparative test across those interventions. Now, the details of what the interventions are isn't critical for the point I want to make here. But the outcome was 4 different studies that provided evidence about each of these interventions. Right? 0 is no effect in reducing implicit race bias, and then positive values are reduced implicit race bias in the expected direction. And we have lots of evidence for interventions that worked to varying degrees. We have stronger ability to make inferences about those interventions that did not work because the exact same procedure and design and everything else cannot be the reason that they did not work. Right? Often when we get a null, we think, well, maybe we screwed up something in the variable or measure. No, that's not possible to account for these because these ones did the exact same thing. And we get comparative data, which is almost unheard of in the ordinary way we do research in the lab, which is we do 4 studies on this one, and we publish those 4 studies on that one and that one alone. And we get no evidence about how is it that that particular intervention compares to other interventions that use different psychological mechanisms or different strategies. And so that's a totally novel innovation in getting information, additional information from the intervention itself versus comparison with other interventions. And so this is, these dots are the individual studies. We did 4 rounds of the contest, and each round they got an effect size of what the effectiveness of the intervention is, and then the white dots are the averaging of effect intervention and the confidence interval. So we got lots of interesting information. Scaling up even a little bit more is the Many Labs project, and this is one of the articles that will be in that special issue I was talking about for registered reports. What we did for this, and this was led by Rick, Kate, and Michelangelo, Rick and Kate are at the University of Florida, Michelangelo's in Italy. We created a 15-minute experiment that could be run through a web browser. And it actually was 13 separate effects. So popular effects in psychological science that could be administered very quickly. So very short measures. So essentially 13 studies in 15 minutes. And we created this single package. And then we said, who wants to run it? And we have 36 different labs or samples. And we're not even necessarily people with labs. They're just people that do research. We have 36 different samples do the exact same experiment with their own setting and their own samples. And we had, so the total sample size was about 6,300 participants. And the goal of the project was to examine a question that is a pervasive concern in psychological science, at least, but is almost never tested systematically, which is how much does the sample and the setting affect the results that we take? Is this particular effect entirely sensitive? It only occurs when you have a particular kind of sample or in a particular kind of setting. These must have big impacts on the result. And so that was the whole goal of the study, is we look across 36 different samples, what's the variation in the observing the effects. And what I'm showing you here are the 13 different effects that we investigated. Anchoring has 4 different versions of the same effects. There's more than 13 of those. And 0 is showing no effect. And each of the little dots is each of those individual 36 samples. The ones in green are ones that are outside of the U.S., the ones in gray are in the U.S. The big dot is the average effect size for that particular result, with its 95% confidence interval, might be 99%. And the blue X's is the original effect size from the study that was replicated, just as a comparison. And so what we obtain from this is evidence about reproducibility, right? Some of the effects are very, very, very strong. Many of the effects are highly reproducible. And then a few of the effects that were in our sample were not reproducible at all. Or at least 2 of them were not reproducible at all. One was barely reproducible. And so we learned something about those. And then we also got to examine the variation in those effect sizes, which was the key point, right? Are some effects contingent on the sample or setting? And by and large, we found that they are not. That there is almost no heterogeneity beyond what is expected just by sampling error, given the sample size. But where there was heterogeneity was actually at the large end of effects. The very largest effects showed the most heterogeneity. Small effects showed the least. And this is actually the reverse of what some people have argued about particular psychological effects, is that those that are the small effects are very sensitive to just getting the conditions just right, and so they would pop out to be a big effect size in the right sample or setting, but otherwise be very difficult to observe, so you get large heterogeneity. We didn't observe that at all, they just didn't show an effect. Whereas the effects that are big showed a good deal of sensitivity to a particular sample and setting, in this case at least. This is not a random sample of 14 effects, but it is an interesting sample. So the point for our purposes is that doing a replication itself doesn't get a lot of reward, but running a very small study on one's own sample that's already been set up is an easy way to get a lot of people involved. And the cumulative data is very interesting for learning things about those particular effects and about comparative data in general. So it provides a means for many more people to contribute to the research process, have big impact kinds of studies, and not try to have just a singular model. You have to come up with a new idea, and follow the process all the way through oneself, but rather work in a collective fashion. So I think I want to stop there and first just acknowledge at the center there's a large number of interns. Almost all of them are currently students at UVA, either undergrad or graduate, across many different programs. And then there's a great staff that is accumulated so far. We just added another person yesterday. I haven't come him up here, now that we're hiring. And we're hiring, so if you're looking for a job, you should look at our website. But I really appreciate the attention and time and questions. So